Good afternoon. Welcome to day 4 of Ignite. I'm sorry, I'm losing days. It's Thursday, right? I see some nods, so that's a good thing. I'm in the right room. Well, I'm Matt Usher. I'm a senior program manager for Microsoft. I work in the beautiful state of Southern California. I live and work in Southern California. And so we're going to talk a little bit about SQL Data Warehouse. So how many of you have already heard about SQL Data Warehouse, know a little bit about it? It's good, most of you. So I'm going to spend a little bit of time just kind of going back through, covering the same message you've probably heard a little bit, talking about what the service is. I'll breeze through that a little bit quickly, and then we'll dive into just kind of how the service works, some of the core components, some of the core concepts. I expect this to be interactive. I don't want to just stand up here and talk again. This is my 3rd session this week. So if you have questions, please feel free, step up to the microphone, ask. This is intended to be an interactive session. So I'll answer as much as I can. There are some things I can't answer, obviously, with a non-released product yet. Uh-oh. Maybe I'm going to do this by hand. So I'll, what's it? Where is it? There you go. Okay. I'll have to do this by hand. So in the course of this session, we'll talk a little bit about what I can disclose and what I can't disclose. So if there's something I can't disclose, I'll just be upfront and honest about it. So the SQL Data Warehouse, it's a fully managed data warehouse running in the cloud as a PaaS service. It's fully managed by Microsoft, and if you're familiar with Azure SQL Database, it's very similar. You go in, you create a simple database, provisions in just a few minutes, and you really get an instance where you can just start working with the product immediately. It's based on kind of 3 core principles that we deliver the service in. The first is this concept of elastic scale. It really means that what we've done is we've disaggregated the concept of compute from storage. And it gives us all kinds of flexibility in what we can do with the way that a data warehouse works. And traditionally, we talk about data warehouses in things like spindles and cores and sizes of disks and speeds of disks and those kinds of things. And this gives us a new set of flexibility and capabilities that we can do with the service. But it really means that the system itself can scale to massive scales, all the way from single petabyte or single tens of gigabytes, all the way up to petabytes of scale. We talk about it obviously being powered by the cloud. It's an Azure service. It's a tier 1 service running inside of Microsoft Azure, meaning that it gets all the full capabilities of Azure itself. We get all the native integration that you would expect. We get all the capability and the redundancy built into multiple data centers, as well as having the capability of being able to launch this service in any one of the regions that are available today. And you're going to watch me pace back and forth here a little bit because I don't think the clicker is actually working at all. And then finally, it really is built on this concept of market-leading price performance. Obviously, we have a major competitor in the marketplace, something that Microsoft will go aggressively and work against. But really, that's not the only value proposition of a service. It's also about the cost of bringing the entire service together. So you don't just run a data warehouse in and of itself. You can put data in it, and you can write T-SQL code all day, but that's not really the true value. The true value is in the integration of other products, things like Azure ML, Power BI, other first-party tools that you would expect, Excel, SSIS, SSAS, as well as third-party tools. I'm a Microsoft employee. I would love for you to run anything that's Microsoft only, of course, but we get that. It's the reality of the case is that most people don't. It's very rare that I ask a question in a room like this and I say, who in here runs nothing but Microsoft stuff? If I get a single hand in here, I would be surprised. And so we realize that. So we're working very diligently to make sure that the entire ecosystem, not just Microsoft products, but our partner companies also work very diligently and very close with us to make sure that their products are certified against the service itself, giving you the capability of running the product in the way that makes sense for your business, not the way that some PM, myself, for example, sitting in a cube thinks, this is the way a customer would use it, and you're shoehorned into the way that we want you to. Really, we're trying to provide a service that works for you and your business in the way that you want it to work. So let's talk about elastic scale a bit. So really, when we talk about elastic scale, what we're talking about is this concept of being able to spin up compute and storage independently. And I'll dive into this a little bit more in just a minute. But what it really means is that this disaggregation is that you have these 2 separate components that you can play with. You can continue to add or remove data and grow that to whatever size you need, or you can add or remove compute. And as you do that, you get the value of being able to say, I can linearly scale this service from one size to the next. And there's all kinds of reasons you would do that. Traditionally, in a data warehouse, you go out, you buy a set of servers, you buy a set of storage, some dedicated network infrastructure, and you would build out a service, and you would size that for the hardest workload you have. Let's take a common case. I'm a traditional enterprise data warehouse, and I have some kind of loading requirement. This is a common use case where I have to get all of my data into the system, aggregate it, all my transformations run, and have it available for my end users to be able to report on during the day. So you right size for that. You have a 3-hour SLA that you have to meet every day. So you build the system for that. The rest of the time, the system's just sitting idle. There's 5 people running reports throughout the day. Maybe you run one first thing in the morning. And the system's really just kind of twiddling its thumbs. You got several $100,000 or millions of dollars of hardware really just sitting in the corner collecting dust for 23 hours of the day. So with the service itself, we give you this ability to basically right size. And I'll actually show you this here in a few minutes. What it means is that you can take the system and you can scale it up and you can scale it down. And the target is that we can do this in seconds. The idea being that you can do this on demand whenever you need it. So imagine that loading scenario. You come in first thing in the morning, you right size the system, you load your data, you run your transformations, and then you right size the system back down. You're paying for the time that you have the system large, and you're paying for the time that you have it small. So you're being very cost effective in the way that you run the service, but you're still meeting the SLAs. And the system itself can grow. So as you start small, maybe you only need to right size from one size to another. But as you grow in data sets, as you grow in data volumes, you can grow the system to even bigger sizes based on what you need. So if we think of scenarios like traditional enterprise data warehouse, where you have this kind of growing sets. I start with, say, a terabyte, and I'm going to add 10 gigs a day. Well, over time, that 10 gigs makes your total size not 1 terabyte, but maybe 1.1, maybe 2 terabytes, maybe 5 terabytes as you grow and add new data sets in. It gives you the ability to right-size your compute to match that data volume. We call this kind of a blended model, so they kind of grow together in a pattern. And really gives you that optimal performance that you've expected from the service from day one. So as the data volume increases, you can still retain that query latency that you would expect out of your data warehouse, even though you're now working with larger data sets. We also have the concept of things like burstable modes. So a lot of times you'll think of in large enterprise data warehouses, they'll have a main central enterprise, and you have this kind of hub and spoke model, or maybe you have a data mart sitting off in the corner. Maybe that's for an enterprise, a department level, something like that. And the system itself can work there. A lot of times in data marts, you think about a set of users. How many of us like to work on weekends? I see no hands. So nobody likes to work on weekends, right? And what that means is a lot of times you have systems just sitting there over the weekend. So you can either right size, or as we talk about elastic pause, you can even size the system down to 0 and enable the service to be cost effective, keeping data in place and using all the advantages of this elasticity, being able to turn it on and off at will. So when we talk about this, it really means that you have capabilities that you never traditionally thought you would have in a traditional data warehouse. If you think about this with physical appliances, physical servers, you really can't just shut the thing off because it doesn't save you anything. You've already acquired the machine, you've already acquired the data center space, and so you're really wasting cost and effectiveness of using that equipment. So when we talk about kind of this transition into pause, it really means that you can take the service as it's running and shut it off. Now, how many of you think about what that would mean if you were running this in a traditional data center? So I have a data warehouse, it's sitting there in a bunch of servers, a single server. I back the system up, I push it over into a backup location, and then I go repurpose those servers. And then on Monday morning, I want to regurgitate that system. So I want to reuse those servers because I used it for something over the weekend, have to restore my data over. This just sounds like a set of steps that is fraught with failure. When we talk about the service running in the cloud, there's all kinds of advantages that you can take advantage of by the services that are available around it. And I'll talk about how this actually works as we get into this, but just think that essentially we're using commodity blob storage and we're using commodity Azure compute and combining the two to give you a service that gives you the capabilities in both of the ways that you're looking at, both horizontally by scaling out compute and vertically by being able to scale storage. And we talk about things like, what's the capability of storage? We literally can take a system from tens of gigabytes to petabytes plus, and that's not even touching the surface of what Azure Blob Storage can handle at this point in time. And as that system continues to grow, and as prices continue to drop, you can think of commodity storage being the place that you can store your data very cheaply without ever having to think of how am I ever going to archive this system, or do I ever have to partition data out of the system and cold store it somewhere else? There's never a need moving forward with systems like this to be able to use that data and compute effectively. So when we talk about kind of the basis of this system, it's really based around kind of this core concept of it's built on SQL Server. The core infrastructure today is SQL Server 2014 CU5. I'll give you the specifics. It's the same thing that you can go buy off the shelf from Microsoft today and patch to the same level that you would expect. It's no different than what you would run in your environment today. It's just done at massive scale and run in the cloud. And it's really built around kind of all of the common core expectations that you would have for a data warehouse running in SQL Server. You have kind of all the core use cases that you would have, common T-SQL languages, and all of those kind of core feature sets that you would expect. So functions and stored procedures, table partitioning, collations, index support. But really when you think about the way that this product has been built, over time what has happened is Microsoft has invested deeply in technologies like cluster column store indexing. And these are really data warehouse specific kind of concepts, and you see those surface in these kinds of products. Specifically in the SQL Data Warehouse Service, custom column store indexing was built about 2 years ago in a product called the Analytics Platform System. How many of you know what that is? Wow, man, this is like the best audience. I've had 3 days in a row of people actually knowing what APS is, which is usually uncommon. But really, APS is, for those that don't know, it's Microsoft's big data in a box. It's essentially an appliance sold that's very large data warehousing. But in those environments, really the technology's evolved so we can understand what happens by introducing things like custom column store indexing for performance. And instead of testing these on small data sets, a terabyte, 2 terabytes, 5 terabytes, these are tested at a very massive scale. Customers running this with 2, 3 petabytes of data. And that's done in these appliance models. By introducing those technologies across the entire platform, not only SQL Server, but SQL Data Warehouse gets to take advantage of all of those components built into the large SQL Server ecosystem. We're talking thousands of developers at Microsoft. I mean, it's truly a database company investing in these technologies. So not only is the service based on a technology that's common that you can use today, but it then surfaces that up at all the advantages that you would get at cloud scale. Again, back to elasticity and scalable storage. The last part of kind of the functionality of the service is really introducing PolyBase. And so PolyBase is a technology that allows you to essentially query Hadoop by using T-SQL constructs. I've shown this earlier in the week. And really what it talks about is the concept of being able to expose data out of Hadoop as something that's simple as a metadata table looking like in SQL Server. It literally is select star from table. And under the covers, we'll do a bunch of work pushing out either a MapReduce or a Yarn job out into the Hadoop environment, or streaming the data directly back into SQL Server, and then being able to allow you to perform operations over it. The SQL Data Warehouse Service will offer PolyBase as a native first-party component. It'll be there on day one of the service. So capability of being able to surface data that you have in existing Hadoop infrastructure, whether that's HD Insight, Hortonworks, or Cloudera, IaaS VMs running in the cloud, or even on-premise based on your connectivity to the cloud, would be exposed through the Data Warehouse Service. So you can take advantage of all the tooling and infrastructure built around SQL Server and the SQL Data Warehouse Service and expose that to your end users, not having to retrain them on technologies like Hive and Pig and Scoop and some of these other technologies built into the Hadoop infrastructure, and giving them all the benefits of the best of both worlds. And so for customers that have a traditionally large data warehouse that they've either kept in SQL Server, or for customers who have very small kind of structured data sets and have very large Hadoop infrastructures in these large data lakes, you're able to combine that data through the T-SQL compatibility of PolyBase and expose it to your end users and really make sense of your data, giving you insights and data that is both resident in your structured systems as well as your unstructured system in a very seamless way. And this is, again, all done with the SQL Data Warehouse Service. Now, one of the things to think about is as these services expand, you can imagine customers who have very small data lakes. So here's where we start to get to the fun stuff. Who has a system that's bigger than 1 terabyte in a data warehouse? Sorry, I make people raise their arms a lot. You get a sore shoulder, so you want to raise. Who has 10 terabytes? All right, how about 20? Do I hear 20? I feel like an auctioneer. 25. Do I hear 25? Oh, I still got hands. I get 2. How big is your data warehouse?
Well, it's on the APS twice.
So how much data do you have in it? 40 terabytes? How about in the back? 40 plus? Oh, okay. Well, you guys are in a tie, so I'm going to throw socks at you. For those in the back, I apologize. Here we go. Let's see if I can do this. Oh, almost. All right. So really, when we think about kind of PolyBase, what we see with the APS appliance, again, this is the same engineering team that builds both these products. Really what happens is we see customers that will do one of two things. They'll either build out a large-scale appliance running, very large, kind of 40 plus, 50 plus, 100 plus, all the way to petabyte plus scale. And they'll run some set of Hadoop. Or what we've seen is we see customers who run out kind of smaller appliances, say 3-node appliances, and they have very massive infrastructure for Hadoop. They land a lot of things there. It's common that we see this. So I particularly have a customer who runs a 3-node appliance, and they have a 70-node Hadoop infrastructure. They use PolyBase as the glue between the two. It's an amazing technology and really allows you to leverage all of the capabilities that you have. As this relates to SQL Data Warehouse, the important thing to remember is that we have this scalable model. So you can scale compute to be able to do some of the things that you weren't able to do today, even in an APS appliance. Because these technologies work in a parallel fashion, each one of the nodes between the two services are talking to each other. And so the operations of moving data between or being able to scale efficiently on both sides is something that's introduced through elasticity. So as you can elastically scale the infrastructure on the SQL DW side, you can gain more performance of actually the Hadoop jobs that are being running by streaming data and parallelizing the infrastructure that's being executed across the two systems. And it really gives you some capabilities that you haven't had today. Kind of the last area to talk about really with the SQL DW service before I start to jump in a little bit more is kind of the symmetry. So SQL DW was born out of this idea that every customer is going to come to us with an application request of a different tool. Now, I don't know how many people are in the room, but if I walked through this room and I asked each one of you, it would be pretty hard-pressed to find a set of people who use the exact same tooling infrastructure. Obviously, we're going to have first-party connectivity to all the things that you would expect, Azure ML and Power BI and ADF and Stream Insights and all those things running in the Azure cloud. We have capabilities of things like pulling data from Azure SQL Database, HD Insight, and some of the other technologies sitting in the Azure cloud. But we also know that this symmetry world also means that we're going to have to include things like a set of partners, all of the third-party partners that we work with, to enable those services to be first-party compliant with the service itself. So we work very diligently with each one of those partners, and the list is growing by leaps and bounds every day, it seems, really to be able to give you the capabilities to plug into the infrastructure where it makes the most sense for you. We want to make sure that the surface area is functional so that each one of these tool sets can come in and natively work with a very large scalable service. And so we work diligently to make this available to you. As we talk about kind of that symmetry, it also means that we have, and I'm not going to have a picture of it here, but it also means that we have the capabilities of reaching down into your environment. So with technologies like Azure SQL Data Warehouse, I commonly get asked questions like, how am I going to load my terabyte of data into this thing? What do I do when I have 100 gigs that I have to push into this every day? And there's all kinds of options. If we have the case here where we're talking about 40 terabytes of data, how would I seamlessly load that data into the system to get started? And there's all kinds of options. Microsoft offers all kinds of things from a service perspective to be able to move your data, whether that's an express route connection, which is a dedicated telco circuit between your data center and the Azure Data Cloud, whether it's an import-export service where you can actually load your data onto hard drives, ship them to Microsoft, and we'll load the data up for you. So there's all kinds of ways to seed the system. And then be able to reach into your environment. Again, if you're using something like ExpressRoute, have the service reach from the cloud down into your environment. So say your Hadoop cluster is sitting on premise. You'd have all kinds of capabilities being able to connect the two. Or whether it's something like a third-party tool, a Tableau, a MicroStrategy, any one of those kinds of technologies that's sitting in your environment could also reach up to the cloud and be able to connect very efficiently. And so we've made sure that we've built a lot of that infrastructure and components into the system to allow you to be able to move on to the SQL DW service as easily as possible. All right, so I'm going to pivot now a little bit, and we're going to start to get into the weeds. So I've talked about this earlier in the week. How many of you know really, truly what the difference between MPP and SMP is? Anybody not know? It's okay if you don't know. So the biggest difference is the way that the architectures are built. And the concept is really a shared versus not shared architecture. SMP is very commonly used in things like SQL Server. They're both common technology or common architecture components, but really when you think of something like SQL Server SMP, what it means is that you're sharing things. The operating system is sharing, all of the compute or all of the cores and memory. So you have this kind of shared model where eventually you're going to find something in that architecture that's a bottleneck, particularly the bus system. So you have kind of a common way to access disk, for example. And so each one of the components, CPUs, memory, the OS itself, is now bottlenecked through that. And you can always buy bigger, right? We all know that there's large SQL Server systems. You can sandbag these, and you can make these systems pretty performant and get pretty big. But if you alternate that against what an MPP system looks like, what you see is that in an MPP system, you're really truly sharing nothing. And it's the coordination of the components working together in harmony in order to make the system perform. And I always use an analogy. It works fairly well. I'm building a house, and I have 1,000 nails to hammer. I can give some person a hammer, and I say, go hammer these, right? And the person just sits there, and they hammer some nails. And I can make them faster, scaling up the service, we call it forklifting, by either making them hammer faster or giving them a nail gun, right? Pop, 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 pop. They could do that. Or I could say, instead of doing that, I go give a bunch of kids a hammer each. Just get 1,000 kids, give them a hammer. Whack, one hit. Who's going to win? Because you're dividing the work across all of this infrastructure, it gives you the ability to scale each component working at such a smaller scale. And so we do things like in the APS appliance specifically, we use commodity hardware. In the cloud, we're able to take advantage of scalable compute. And so we can use much smaller infrastructure to save costs, but also performing or outperforming something that would be based on an SMP model. So we can take something that doesn't seem to make sense. I'm going to have either less cores or the same number of cores, but I'm going to have a lot more data to process. And it works very efficiently because each component in the system is only having to work on a very small slice of data. And it becomes a very performant and very optimized system on the way that you're spending money, as well as what you're able to the capabilities that you're able to execute within the system. So it really kind of gives you the best of both worlds. Obviously, everybody seems to be calling it the Scooby-Doo magic. The Scooby-Doo magic, which is a US reference, I apologize, is truly the orchestration of that, right? This is a very similar model that you see in things like Hadoop and other services. And so it's nothing that's a new architecture invented by Microsoft. It's a common industry practice. But the magic is truly coordinating this and making it efficient. And doing that is not trivial. It's something that takes a lot of time and a lot of thought, as well as making some trade-offs. Just like there is in the SMP world, there's always pros and cons in what you can do in an MPP world. And so we're going to kind of dive into some of that technology and talk about kind of how all this stuff works under the covers. We're going to start with then what happens to the data. So we're going to start with the concept of a distribution. And really what this means is when we talk about data, when you insert data into an MPP system, what we want to do is we essentially want to give each component of the system just a slice of the data. So if you think back to the hammer analogy, we want to give each kid one nail and give them the capability of only having to work on a very small set of data. And this in the world of MPP is called a distribution. So when we think of the way that you would create this concept in the MPP world in SQL DW service, you'll have a very simple construct. Create table, which is the same syntax that you would see in SQL Server. You'll also see it in SQL DW. It has an additional component, this with clause. So if you're familiar with creating cluster column store indexing, it's the same syntax kind of model. But in this case, you can see I'm creating a distribution based on a hash. And so I'm giving it a column that I want to hash. And I'm saying base the data being split across based on the column. And you would do this for performance reasons. You want to keep data that's very similar, often queried together in a single component so that it's very performant at query time. But you really have this option of that's the way that you split the data. You also have the option of splitting it over a round-robin component. So it's just like it sounds. Row 1 goes in distribution 1, row 2 goes in distribution 2, row 3 goes in distribution 3, and it works its way through the number of distributions and then starts over. And it continues to do that, so it just evenly balances. And what this means is this is a way, from an MPP system perspective, on how you divide and split data. And if you think now back to that nail analogy, if we had, say, 1,000 kids each with a single nail, if I wanted to add another 1,000 rows, each child only gets 2 nails. Probably nails and kids are probably not the best example, but I was thinking about my young kids today. We're building a chicken coop, so that's where the analogy comes from. But each person only has to execute with a single hammer and 2 nails. But if I went back to that single person model, it really means that that one person who had 1,000 nails now has 2,000 nails to work on. So you can see the efficiency that's gained. And so really the concept in distribution means that each set of working components only has to work on very small slices of data. So when we talk about things in hundreds of gigabytes or thousands of gigabytes into terabytes and petabytes, you're really still only asking the system to work at a very small scale. Again, it's the coordination of how all this works, which is where all the magic is. So this gives you the ability to basically define how your data gets distributed and then controlled. When we jump into the way that the SQL DW system is actually architected, you actually see 2 components that you probably either, if you're familiar with APS, know what these are, but if you're not, are new concepts. And they're the core MPP engine that's built to be able to run all of that magic, and a system called the Data Movement Service, or DMS. And these 2 things in conjunction actually are what execute all of this infrastructure and do all of the coordination or the magic that controls all of the way that a query is executed across the system. So when we think about something like the MPP engine itself, in and of itself is just a control, or if you're familiar with Hadoop, the head node. And it's essentially just the coordination system. It manages permissions and security and all of the metadata of the tables. But it's not actually doing any execution. It's really there for just the control or the management of all of the rest. The DMS service, and I'll dive into what this is the coordination of the data across the infrastructure. So if you have data that happens to be in a single node, and it needs data that's sitting in another node, it's truly a peer-to-peer topology of allowing the data to flow between the nodes so that they can communicate with each other and deliver the appropriate sets of data into the appropriate nodes for execution. At the bottom, when we really look at what a compute node is, it's really 2 core components. SQL Server, just running under the covers, with just a set of data that's sliced at it. And then the Data Movement Service, which coordinates the communication between it and itself and any other nodes. And these two components built together means that we can do all of this distribution and coordination across all of these nodes and achieve very high scale. When we talk about what this means from a customer's perspective, I use a bunch of examples. So there was a customer who had approached us about a service that they were running today in a large data warehouse. It was about 12 terabytes. And they have a query that takes just over a week to execute in a SQL Server SMP system. It's about a $2 million system, very large SQL Server with a sandbag. And it really takes about a week to execute the query. We went into the environment, and we asked about all kinds of things. What kind of data do they have? How are they distributing the data? What kind of loads they have? All of those things. And it became very, very obvious that really the problem they were having was just a scale-wide problem. So we went in and we took a very simple appliance in this case, and we took the model and we said, we're going to divide your work into just a very small system. In this case, it was a 4-node or a half rack, we like to call it, basically 4 compute nodes. And we divided and conquered. Without any changes to the infrastructure, we took the query that took just over 7 days, and it went to 37 minutes. Just by simply lifting the data and putting it in a system that's now distributing it. And you see the amazing scale. When we went and spent some time tweaking and tuning that query, it went from 37 minutes and optimizing for running in a parallel model from 37 minutes to just over a minute. So you went from a query that took 7 days to run on a multi-million-dollar system to just over a minute. And we were using half the hardware. And it's amazing what you can do with this just by the coordination of distributed query plans, distributed data, and allowing each one of these components to work at scale. When we talk about turning this into the SQL DW service, what it means is that you can take advantage of all of those things and not have to buy that expensive hardware and not have to worry about how do I get it on site, how do I move my data into it, how do I continue to allow it to grow, or how do I optimize my cost, and do this in a way that you would expect at cloud scale. I could turn it on and off at a moment's notice. I could scale it at a moment's notice. I could really grow the system to meet the needs of what my business needs today without having to go through the expense of really having to build out a system like that. So I'm going to break down compute a little bit further for you. And I'm going to explain how it actually works. So when we talk about kind of the system itself from the SQL DW perspective, there's 2 kind of core components that happen on a compute node. We really use Azure Commodity Compute. Inside of Microsoft, there's a different avenue that's available to us as a running PaaS service, but it's the same public Azure Compute that you do. We can be able to hide it as a PaaS service, and we retain all of the management responsibilities. So if you went out and lit up an Azure VM, had Windows Server 2012 running on it, for example, you're responsible for patching and maintenance on all those. Running as a PaaS service, Microsoft is responsible for that. So from a compute perspective, it's truly just compute. It's CPU, it's cores, memory, and then a core OS. And running on just those Azure compute nodes, and it's really our responsibility to control and manage all that. It's part of the PaaS model. From a storage perspective, we use Azure Blob Store. Specifically, we use page blocks, and we use geo-redundant page blocks, which means that your data is written 3 times in the data center that exists, and then it's mirrored to a partner database or data center in another 3 pairs. And I kind of simply modeled that here. I didn't draw six boxes just because it didn't fit the slide. But the concept is that your data is always resident somewhere in 6 copies. So you never have to worry about your data being lost. You never have to worry about your data being, fractured in some way that you can never recover it. And the idea is that your data is distributed in a single data center. And I'm going to pick a real example. So if you went out and lit up a SQL DW instance and say US North, I'm going to pick one of the data centers I'm familiar with, and you started writing data in it, there would be 3 copies of the data sitting in US North. Immediately, the system under the covers redundantly copies that into the US South data center. So not only could you lose a rack of servers inside of US North, there'd be 2 other copies within that data structure. And from a user's perspective, you see none of this. It would just happen automatically, and the data would be redundantly restored, and you'd just continue to work. From your perspective, it just works. The redundancy is built into the system. But let's imagine the worst thing happens. US North gets hit by the most significant historical snowstorm that ever existed, and it shuts the entire data center down for some reason. That data is automatically copied already to the US South data center, and your data exists. So the redundancy is built into the system that you never have to worry about your data disappearing on you. And all this is guaranteed and backed by the Microsoft SLAs for storage, as well as the SLA that will come with the general availability of the SQL DW service. The same thing happens in your compute. So if you think about running an infrastructure today, even with physical hardware, if you happen to have a hard drive go bad, or you have, for some reason, a motherboard go bad, or a memory chip go bad, even in these redundant systems, you still have downtime. You still have failure cases. In the case of the SQL DW service running in the cloud, all of that's handled by the Azure infrastructure. So if we have a VM go down, for example, or a compute node go down, or there's a patch cycle that needs to be a security patch that needs to be applied, that's all handled under the covers by the PaaS service, that's SQL DW. We handle that, we'll take care of all of the patching, and we'll make sure that your service stays up so you don't have to worry about absorbing that downtime. It's something that's available as part of the PaaS model with Azure SQL Data Warehouse, as well as all the other Azure services. So now that we have these kind of core concepts, let's talk actually about how a query moves through this system. So when we think about what a query is doing, and all of the components now that I've described to you, it's somewhat of a fairly complex process that I'm going to simplify here. So you have a client, whether that's a third-party application, whether you're sitting in a command prompt with a SQL command, or however you want to compose the query, that's executed inside of the control node. So that's your first point of contact. And what the control node will do is it will make a determination based on the type of query, where to actually execute the query. In the case of something like a metadata query, it'll redundantly pull locally from the data that it has. So if you said, I want to get select star from systables, it'll just use the shell database that it has locally, and it'll respond immediately. In the case of something like select star from user distributed table, let's say it's products, and we have that across split across as a hash distributed table across multiple compute nodes. What will happen is the control node itself will create a distributed query plan. So from a SQL perspective, it's similar to a SQL Server execution plan, where you'll get to be able to see, here's all the steps that are going to be executed. In this case, the query plan is also optimized to understand which one of the nodes has what set of data. And then it will send an individual execution plan to each one of the compute nodes for it to process. And so the compute nodes themselves really know nothing about any of the other nodes. It's traditionally just SQL Server just sitting there answering a query. Select star from this set of data that you have. And so each node really doesn't have to worry about, hey, is there data sitting somewhere else that I have to worry about? Is there, how do I go get data from compute number X because I'm compute Y and I don't really have that data? It knows nothing about those other systems. It's truly just optimizing SQL Server for what it's been doing for the last 20 years. Give me a query, let me execute it as fast as I can, and optimize that query as fast as possible. And so as this query moves through the system, we think about now going into the weeds. So from a control node, this query tool comes in and it'll walk through the exact steps. It'll parse the SQL itself. It'll do validation and authorization to make sure that the caller of the query is actually authorized to connect to the places in the data that it's set. So if you granted or denied permissions, for example. It builds that execution plan from an MPP perspective, and then it'll go execute it. And when that execution happens, this is actually the flow of what happens. It will send that out to the individual node, and it will execute the query. And then depending on the type of query, aggregation will either happen at the node level or it'll happen at the control node level. Very rarely does it actually happen at the control node level. Most of it's done at the compute. And when we think about where all of this stuff lives, you can see the concept of a control database, the global tempdb, and those things. Those are the logical master. Those are all controlled by the control node itself. SQL Server down on the individual nodes still has its local resident tempdb, for example, if it needs tempdb space for something. Qtables, those kinds of things. But really, it's focused on just executing queries. I know I'm spending a lot of time on this divide and conquer model, but it's really important in understanding this concept of really splitting data. And it takes customers time to make that transition from thinking about how would I process something in SQL Server SMP, say like a row-by-row operation where I'm just doing single-level inserts, to this concept of batching, where you're really allowing all of the power of the compute infrastructure to be able to operate at the same time in parallel. And those two concepts, as you start to move and migrate from an SMP view of the world to an MPP view of the world, really give you some kind of performance advantage that you've never seen before. All right. Now, here's the question that always gets asked at this point. So what about data, in the case of, say, a distributed table, that I need that doesn't exist on the node that I'm on? How does that work? So I distributed a table, and I'm running a query, and I'm on node A, but I actually need a piece of data that's on B for some reason to satisfy my query. Well, when I think about what this does, we talk about this service called the data movement service. And it's essentially a peer-to-peer infrastructure that allows the data to be transferred appropriately between the nodes. From an individual's node perspective, it just asks for the data, and the DMS system interprets that and makes a request in the appropriate location to get the data and surface it before SQL Server actually executes. So if we think about the way this works, it's essentially no different than peer-to-peer networking. Right? You have multiple nodes all talking to each other, and they have some concept of where the data lives. And by being able to pipe data from one service to the other, you get to take advantage of each compute node just having a sole focus of not having any concept of what else is there. When we talk about elasticity, this means that you can insert nodes or remove nodes at a moment's notice, and the topology management of all of this is handled by the SQL DW engine, and it gives you the capability of being able to add nodes and have the data move seamlessly between the system without actually having to touch it. So when we talk about then adding an additional node, for example, it just pops itself into the infrastructure and starts communicating with the other nodes. It does it automatically. There's nothing for you as a user to do, and there's nothing from you as an administration perspective. And as we add additional nodes, we really see that this infrastructure can then bounce back and forth. When we talk about this, though, we start to talk about performance. And we think of things like table design really improving the way that the performance works. And I'll give you another example from a real customer. We had a large insurance customer approach us. They had purchased an appliance in the past using the same kind of MPP technology. And they had all of their tables set in a way that their queries were slow. Even though we'd gone through this whole pitch of why MPP is faster and we'd done some POCs and all those kinds of things, they still couldn't get the performance out of the system they were expecting. And doing kind of an analysis of the queries they were running, we realized that they were doing what's called a shuffle move, which is essentially this concept of taking a distributed table and based on the way you've distributed it, having to redistribute it in order to make the query perform. And so that's done by the MPP system under the covers, but it's an expensive operation. You could imagine on a row or on a table with 10, 15, 30 billion rows. In this case, it was about a 70 billion row table, having to pick all that data up, redistribute it into temp tables in an appropriate way to actually execute the query appropriately. Given the system they had, we did something as simple as a CTAS, a create table as select, alternated into, I'll get to your question. You can come up to the microphone and ask the question.
I'm not going to reach the mic. I'm louder this way.
Okay, it's just for the recording. So let me finish this and go ahead and ask your question. We were able to CTAS the table using a different distribution ID, and we saw the query go from hours to seconds, just because we optimized for the way that the data is going to be moved from the system. And so we weren't moving that 70 billion row table. We actually ended up only moving about 100,000 rows between nodes. And we can do that very, very efficiently using DMS. Go ahead and ask your question.
Are you trying to redistribute the data so it is evenly placed on all the compute nodes? Or is there a different way? Because if data is skewed, there's too much of data on one node, and you're going to have performance degradation.
Yeah, so I'll repeat the question for the recording. So the question is, are we trying to optimize for data not being skewed across nodes and allowing not an individual node to have heavy data versus all of the other nodes so that it's performance imbalanced? Somewhat yes and somewhat no. Sorry for the non-deterministic answer. In the case of a round-robin distribution table, it will be by default evenly balanced, with the exception of partial rows that don't cover all of the distributions. In the concept of a distributed table, the answer is generally no. Obviously, we give guidance of trying to balance as evenly as possible and optimizing which distribution key you pick. But there are cases where you have, say, 5-10% distribution skew across the nodes that actually doesn't make a difference in the performance based on the types of query you're running. So generally, the guidance is try to keep it as evenly distributed, but some level of skew is actually really doesn't hamper the performance of the system. If you get to the place where you have 70% skew, so one node has 70% of the data and the other nodes have a split of the remaining 30, you're going to have performance problems, and that's really where we run into going back and looking at systems and trying to rebalance. It's a great question.
And that's what DMS does?
In that case, no. So DMS actually wouldn't move the data because, say, node A that has 70% of the data still knows that it's only optimizing that data. The only place that DMS actually involves itself is either you're doing something like an aggregate, where you need to pull additional data over, or in order to satisfy the query. So say you're missing 10 rows. It'll go find those 10 rows and pull them into the local instance for the query to be executed. It's really only doing that peer-to-peer, making sure you have the complete data set to execute. It was a great question. So I figured at this point, everybody's kind of sleepy, right? Everybody just had lunch. I kind of have this monotone voice. We're just kind of cruising along. I'm talking about deep technology stuff, and everybody kind of glosses over. So I figured I would do something a little different. All right, back to the socks. I used to be a baseball player, so I like to throw things. Sorry. So who's ever heard of PDW? All right, good. This is going to be fun. Anybody know the name of the company that we acquired in order to get PDW? Shout it out at me. There's two of them. All right, you get one in the back. Oh, almost. You get a pair of socks in the front. Okay, so I figured I'd just kind of wake you up a little bit. This time in the afternoon, everybody gets a little sleepy, so I try to do something a little different. So I figured instead of actually just continuing to stand up here and talk about this stuff, I'll actually show you. So I'm going to run just a quick demo here. And this is a live demo. Oh, hold on. We got to get to, why am I not seeing, PowerPoint. How do we get the desktop on this thing? So I just close PowerPoint? Yeah, there we go. I'll have to slide this over. Okay, so if you saw the foundation session, this will be the same demo you saw there, but I'll talk a little bit deeper as to what's actually happening under the covers here. So this is a real running instance. It's running in a development VM. We haven't pushed the code into the public portal yet, so the VM itself is just running the portal experience. The live underneath SQL DW instance is running in a live production instance, so the same production data centers that run all of Azure. And what you're looking at is the provision, or the instance blade, we call it, which is an individual running instance of SQL DB, or DW. And it has some core concepts, right? It has all the things that you're familiar with. It has, the essentials blades, if you've seen the new essentials blade. And it has this concept of DW, which is essentially the compute model that we're using. Under the covers, we will optimize, and we'll publish what we define as a DW, but you'll buy things in blocks of compute power. So no longer are we going to have the conversation anymore about how many cores, how many spindles, what speed spindles, all of those things anymore. We're done with those conversations. Because in the data warehousing world, those are always the conversations that were the result of, hey, I just want to know how many customers did I lose last month? How many customers did I lose because a competitor did something? How many customers did I gain last month? And why did I gain them? Those are the questions you always wanted to answer. But we built technology, and we ended up having these conversations. Well, in order to answer that question, you have to have 10 cores. And you have to have 3 terabyte drives that spin at 15,000 RPMs. And that's the way we answer the question. As we move forward, those things become less and less important. It doesn't matter how much compute power you have, because it's literally slide it over and make it bigger, and you'll get more power. We no longer have to think, how do I right size for this 3-year hardware cycle that I have to go buy, and my boss is going to approve, how much hardware I'm going to need? Okay, I need to right size. Well, what happens if we spike another 10%? How big does the system have to get? It's not that conversation anymore. I'm going to do it here live in front of you, and I'm going to show you. You can do this on a moment's notice. And you could take the time to say, I could do this when a customer needs this on demand. I can do it if my boss walks in my office and says, I need this query, and I need it in an hour. And that's a 3-hour query. So I just size the system up, run the query, and then size the system back down. So I can get the answer quickly, right? There's all kinds of reasons you would do this. And so be patient with me. This is still, like I said, running code. Our developers actually refreshed this morning, so fingers are crossed. I wanted to show you live, actually, a running system. So what we're going to do is we're just going to double the size here. Oops, went a little big. And I'm going to save. And what the system is doing right now is it's actually going out and it's building out new computes. It's adding additional computing power into the infrastructure. So this is literally provisioning VMs, lighting them up. And at this point, then, it's going to redistribute the data across. So it's looking at taking the nodes that we had and all the distributions, and it's reattaching them to the compute. And this is actually going to take about 60 seconds or so here in this demo. But really what that does is it means that it allows you to scale this in a very short period of time. And as that's happening, your data doesn't move. There's no concept of having to move your data. We're not shuffling. We're not doing any of those things that you would traditionally do in a data warehouse to move your data around, those things that take hours. I'm personally the PM responsible for a concept called add unit in the APS appliance, which means you bought more compute and more storage, and now we have to distribute your data. And I can tell you we've spent hours and hours and hours of engineering time trying to optimize how fast that can happen. And I don't care who you are, whether you work for Microsoft or not, there's nobody in the world who can take a very large set of data, and when I say very large, I'm saying a terabyte, 500 gigs, and move that efficiently across from one set of databases to other sets of database in any kind of time. No company has come out and said we can do this in seconds, and yet what you're seeing is that that just happened in front of you. So the time that it took me to say that, in about 50 seconds, I just moved you to a larger system. We went from one size to another size in 50 seconds. It was done live in front of you with development code. But it means that you now have twice the power that you had just a minute ago. So if I took a query that was, say, taking 30 seconds a minute ago, it'll now take 15. And if I doubled this again, it would take 7. And this gives you the power to be able to do this whenever you want to do it.
But I don't know how you can do that when you're not moving the data. It's all about NPP, and you're looking at different, and you're looking to run it in massively parallel. You just added a unit, you didn't shut the data, and yet you're faster?
Mm-hmm. What's that? Haha, so this is the magic, right? This is for the folks in the US, there was a cartoon called Scooby-Doo, and they had this thing called the Mystery Van, and that's where this comes from. So that's the Scooby-Doo magic, right? Under the covers, there's some proprietary technology, and unfortunately, I can't actually explain it to you here on stage. We're not publicly released yet, and so, but you can imagine that we're essentially adding compute without moving data. I won't tell you how that's done, but that's the concept, is that the compute is now able to scale that data across without actually having to take physically data and move it anywhere else. The data remains in place, and we add compute. I'll let you kind of imagine how we do that, but there's some proprietary technology. What's that?
I'll come with you later.
Yeah. But there's some proprietary technology that allows us to do this. And like I said, you saw this live, done in front of you. This wasn't make-believe. This wasn't, if you attended the foundation session, you actually saw the first screen blow up on us. This is real code running in a real data center, and it actually just worked in front of you. And this really gives you a capability and a thought process that you didn't have, when you walked into the building on Monday. All of a sudden, now you have this technology that you can do things that you didn't want. And this is an actual workflow. This was from a large retailer here in the US, and they use this to do demand forecasting. And this is an Azure ML workflow. And you can see we have native connectivity to Azure SQL Data Warehouse right in front of you. So in this case, it can go read data, and the two systems are optimized. So if we just had Azure ML select star from table in this case, because we're doing a simple example, if that happened to be a 10 billion row table, how would we optimize the data movement between the two? So we use a concept internally called direct connect. And that technology allows us to stream data in parallel from our system to theirs. In this case, because I'm doing something simple as a select star, it's going to stream all of the data. But Azure ML, ADF, Power BI, they've also implemented this technology to understand that when it connects to something like SQL DW, more often than not, the service that's going to have the power is going to be the SQL DW system. So it'll take advantage of the computational power that's split across all of these compute nodes, executing at massive scale. Again, back to those people hammering nails. Instead of having one person do it in the Power BI side, we let the power of the appliance, or in this case the SQL DW service, extend out into MPP, execute in parallel, and return the data very efficiently and stream quickly between the two services, allowing you to do, for the first time, very large-scale analytics across massive amounts of data, whether that's 100,000 rows, 1 billion rows, 10 billion rows, 100 billion rows, even into trillions of rows in a single table being able to be pulled into an Azure ML script for execution. And then at the bottom of this workflow, you'll see the opposite. So as the data is moved, you're executing, in this case, a bunch of R scripts. We'll go down to the writer. Oh, this thing's doing some funny stuff. We'll go down to the writer. And you can see using that same infrastructure, you're able to push the data back into the system. So in this case, we're actually using a staging instance. And it's going to pull the data out, it's going to run the script, and it's going to push it back into the system as a demand forecast. And this is a common use case in retail, for example. How many sweaters do I need to put into Chicago because the weather's going to be cold? Right? How many sweaters do I need to put in Southern California because the weather's not going to be cold? But people there have thin skin, so they generally wear sweaters in the wintertime. Right? And so they use this kind of historical data, and they try to forward forecast. It's pretty common. You also do these things for things like credit card fraud, other kinds of intrusion detection in security systems. And it's common to have these kinds of use cases. But people have always had a traditionally hard time doing this at scale. In the cloud service, you're able to take all that data at scale and perform it through these kinds of workloads. And with the introduction of things like the Azure ML Marketplace, you're able to take not only scripts that you have to build, because I can guarantee there's probably 5 people in this room who, if I asked, have a data scientist working in their environment. And I'll ask, who has a data scientist that works for your company? So, okay, maybe 10, right? There's very few people who can actually build this. But giving something like the Azure ML Marketplace, you're able to import scripts written by other data scientists. You're able to buy them or purchase them or grab free ones off the marketplace and interject them into your workflow, allowing you the capability of doing this on data sets that you have today. Using the power of something like PolyBase, you're able to pull this not only off of data stored in a relational data set, but also non-relational data sets as well. And you get all the capabilities and all the power of MPP, PolyBase, and Azure ML in a single system. So now, if you saw the foundational session, we'll go over to Power BI now. And this is this canonical scenario of that same retailer, and they're doing pricing promotions. They're saying, hey, my competitor 2 doors down, it's the holiday season. They just put a promotion out. What's happening? And I'll wait for the filter here to pop up. What's happening is under the covers, this is actually connecting into the Azure SQL Data Warehouse, and it's running a large set of queries. Yeah, I had a feeling. Power BI likes to reload after you let it sit for a while. So as this kind of comes back up, what this is doing is it's a direct connection from Power BI running in the cloud to SQL Data Warehouse running in the cloud. They're both in production instances. And what's happening is under the cover right now, it's running about 30 queries across the SQL DW system and running large aggregations. This is running over, I can't remember what the data set is, but it's a fairly large data set in the order of terabytes, I believe. And so what it's doing is it's doing a simple model. It's not super complicated, and it's for demonstration purposes. But as it's running these queries, it's trying to determine impact on margin, answering a business question. What's going to happen if I do a pricing promotion? What happens if I do this in all kinds of different places? And because we've increased the power of this system, not only in this default view, I'm going to go and I'm going to say, well, what happens if I do something simple? Like I'm going to do a 20% price promotion because my competitor just did that. I want to see what happens. This retailer in particular, they have a system in place today to try to do this. Once they have the data in place, which takes them about a month, when they call up their IT department and say, I want to do a pricing promotion comparison in Arizona on this store because right down the street, the competitor just popped a 20% sale. And so it takes them about a month to actually get that data in place. Once they have it in place, running this exact same system, it's the exact same code. We just lifted it and put it into a SQL DW instance. This entire infrastructure takes about 7 hours to run. I just walked from here to there, and it took 8 seconds to do that same exact query using MVP at scale in the cloud. Now, the thing that they really want to do is what I'm about to show you, which is, hey, I'm an individual, but I want to go see this across all the stores. And let's see if this will actually come up. I want to be able to do that same price promotion comparison across all of the stores. In this case, you could see I picked store number 845, and I'm just going to go clear that filter. And this will start to execute here in just a second. And what's going to happen in about the next 10 seconds is we're going to run that same aggregation across every store for this product segment. And in this case, you can see I picked a couple of types of things, men's denim jeans, women's denim jeans, and a couple specific products. I'm going to watch what happens. The promotion price, the impact on margin by a 20% promotion across all of the stores that I have. In this case, thousands of stores across the country. And this is a real-time analytics or an Azure ML scenario where the execution of this is happening at scale inside of a SQL data warehouse. And it happened in seconds in front of you. This is actually something that retailer could never do. They've tried it with very large systems. They've tried to build this out. And it took them 5 years to get to a point where they gave up. And they came to this and they said, this is the hardest scenario we have. If you can solve this scenario, we'll purchase the system today. We spent about 2 weeks of our time just porting the system over, took their data and put it into the system, and you can see, I can do it on stage here in 10 seconds. When it took them 5 years with millions of dollars on all kinds of the infrastructure, we're able to duplicate by just simply giving them the power of scaling the system to meet their needs. In this case, I gave it about 1,000 DWs to let that perform in a very fast fashion across all of these different nodes. So it really gives you the capability, and this is just a simple example. Obviously, there's a lot more complex examples, but it gives you a simple example of the tie between things like Power BI and how you can quickly get at the data at massive scale and run this in this MPP model across all of the distributions that you have and do it to solve a business problem just like that. So if I happen to be sitting at my desk as an executive and I walked in and I said, Mr. and Mrs. Employee, figure out what am I going to do today? How do I go to my boss and say, hey, my competitor did X, and I need to respond. And I need to know now, based on all our historical data and all the forecasts we have, what the impact is going to be on my business. Can I do that in a moment's notice today? No. Can I do it now, given the power of SQL DW and all the capabilities we've lit up? Yeah, you'll be able to. Again, shown live to you here on stage. It's really something that's a unique capability of the service itself. All right, I'm going to flip back. Oops. So I'm going to kind of end here and leave a little bit of time for questions, any additional questions you have. But really, the SQL Data Warehouse is built on these 3 things. It's built on elastic scale and performance. It's built and powered by the Azure cloud. And it's really built in a price-performant way. So we optimize the system for your needs. Again, as the PM, there's multiple peers of mine. We sit around and we think about what are all the use cases that customers have and how can we solve those? And we came to the realization, we're never going to be able to solve this. Once we light this service up in the cloud, we're going to see a variety of use cases, things that we hadn't even imagined that people will be able to do with this system. And so we want to give the power back to you. We want to give you the capabilities of controlling the system in a way that works for you. And so that's what the SQL Data Warehouse is. So at the end of this, if you want to find out more, you can go to aka.ms/SQLDW. And there you can learn a little bit more about the service, as well as sign up for the public preview. And as soon as the preview comes out later this summer, you'll have access to be able to go in and start trying the service yourself. I'll take questions, but thank you everybody for your time. If you have anything you'd like to ask, feel free to come up to the microphones or catch me after. I'll also be down in the booth later down today on the expo floor, so if you have any questions. Otherwise, thank you for your time.